Dimensional analysis is a pretty powerful tool. While we can use it, and we usually do, to do unit conversions, it's bigger than that. We can use it to estimate unknown values from different quantities that we do know. Especially when we combine it with the idea of modeling. Putting those two together, we're able to get pretty good guesses on obscure things that we just don't have much of a clue about. I'm going to look at estimating how many golf balls can fit inside of a school bus. That's definitely not a number that I know offhand or even have any kind of a guess at. So I'll start with that. This is going to be about estimation. And it's really an estimation example. Alright, how many golf balls can you fit inside of a school bus? I'm going to start with something simple. If I have maybe the volume of a golf ball and the volume of the school bus, I can divide and I can get there, and that's going to be hopefully a pretty good guess. So a golf ball, that's a sphere, and it's going to have a diameter of, I think, about 1.5 inches. I don't think it's as big as 2 inches, kind of holding that up in front of my face, like holding my fingers a couple inches apart. I don't think it's quite that big. I don't think it's as small as 1 inch. So 1.5 inches seems like a pretty reasonable guess. I know I can convert to centimeters and meters and what have you. I'm sticking with inches in this case because that's how I think of the size of a golf ball. It's a good scale for it. So what else do I need? I'm going to need the dimensions of a bus. Now, I'm going to look at each dimension separately. I'm going to say that the inside of a bus is more or less a rectangular prism. I mean, it's got some amount of curve, it's got some amount of whatever, but this is going to be pretty close, and now I'm modeling. So what I would like to do is get the dimensions of this thing. I'm going to say I need a length, I need a width, and I need a height. If I'm going to model this thing as a box, that would be enough. Alright, I'm going to start with the width. I know that I can't lay down across the seats inside a school bus, but there's a row of seats or there's a bench and then an aisle and then another bench. I can't stretch out across a bench, but if I lay with my head against one wall of the school bus, I know my feet wouldn't hit the opposite end. So I could lay across it if there were a bench the whole way across. Two of me couldn't lay end to end. I'm going to guess that the width of a school bus is something like 8 feet. I'm about 6 feet tall. I'm 6 feet tall, so there's 2 feet below my feet. If I lay with my head against one side of the wall, that feels like a pretty decent estimate. So I'm going to call this thing 8 feet. What else? I can stand up inside a school bus, so the height has to be at least 6 feet. I've got a little room above my head, so it's more than 6 feet, but some of the guys on the basketball team and on the rugby team, they can't stand up straight. So I'm guessing that it has to be less than 7 feet. I'm going to say the height is probably about 6.5 feet. That's 2 dimensions down. That's not too bad. Now I need the length, and that's kind of the harder one. I think that there are 12 rows in a school bus. 12 rows of benches, 2 people per bench, so that's 24 benches, or 24 people, and then 2 rows of benches, right? That means 48 people inside the bus. That feels like a pretty decent guess to me. I'm going to add in another row for the driver. So 12 rows plus 1 driver. 12 is also one of those numbers that comes up a lot when you're building things. So I think it's more than 10. I think 15 is probably too many. 12 seems like a pretty good guess. So I've got 13 with the driver. I can sit with my back against the seat, and my knees will be against the seat in front of me. So I'm going to guess that each row is about 2 feet. 2 feet per row times 13 rows gives me 26 feet. I want to add a little bit more because the seats themselves have some amount of thickness and there's maybe some extra room in the front. I'm going to call this thing 30 feet. So I have a length of 30 feet. Okay, I have dimensions, maybe. So I'm saying I have a volume, because I'm modeling this thing as a box, I have a volume of length times width times height. So 30 feet times 8 feet times 6.5 feet. And that gives me 1,560 cubic feet. It's a big number. Might be fine. Back to my golf ball. The golf ball, I said, has a diameter of about 1.5 inches, and I'm going to treat it like a cube. I know it's not, but I know that when I put a bunch of golf balls into some space, there's going to be some gaps between them, so a sphere is harder to work with. I'm going to call it a cube. So the volume of this thing is going to be 1.5 inches cubed. 1.5 inches, cubed, which is 3.375 cubic inches. And I don't particularly like that. There will be gaps. The gaps won't be huge. I'm going to round this down just a little bit, and I'm going to say this is 3 cubic inches. So I've got a golf ball being 3 cubic inches. I've got the volume of my bus being 1,560 cubic feet. Let me try this. 1,560 feet cubed for a bus. I am comparing to one golf ball being 3 cubic inches. So I need this feet cubed to be in inches cubed. I'm going to convert that first. I know 1 foot is 12 inches, and it's a cubic, so cubed. At this point, my cubic feet and cubic feet can cross off, and I will be left in cubic inches. I said one golf ball is going to have an effective volume of maybe 3 cubic inches. And when I do this math, what I end up with is 900,000 golf balls. That is a really big number. Let's see how good this is. The inner diameter, or the inner dimensions of a school bus, so this is my guess. This is my estimate. The inner dimensions of a school bus are actually things that you can look up. The length, remember we said 30 feet? Looking this up online, the length of a school bus is 25 to 35 feet. Apparently it's not quite standard, so I feel pretty good about that. We are right in the range. The width, I guessed at 8 feet. Actual number, inches. Of course it's in inches. 102 inches wide, which, going into feet, gives me 8.5 feet. That 8-foot guess really wasn't bad. And then the height, I said 6.5 feet. And the actual height inside a school bus is 6.5 feet. Got that one dead on. So we are doing pretty well. The total volume of a golf ball, that was the other thing we needed. We said the volume of a golf ball I said 3 cubic inches. The actual volume of a golf ball is 2.48 cubic inches. So I was a little bit over, but that's okay. We're not doing bad at all. Moment of truth. We said a golf ball could be effectively represented as a cube, and there's a little bit of difficulty in there. The average packing density of golf balls is, so average packing density, I'll talk about what that means in a second, is 0.74, which means I can actually do the math and find how many golf balls would fit inside a school bus. I'm going to stick with the 30 feet. It falls right in the middle of my range. I'm calling that good. So 30 feet, I'm looking for the volume of the bus. I've got 30 feet times 8.5 feet times 6.5 feet. And that gives me 1658 cubic feet. Remember, the number that we came up with before was 1560. So right within that range. We're doing okay. I can now figure out how many golf balls fit. 1658 cubic feet. Still have to convert to cubic inches, so 12 inches in 1 foot cubed. 1 golf ball is 2.48 cubic inches. And we have that packing factor of 0.74. That just means we can't, so if we could melt down the golf balls so that they were just their volume and fit whatever container, like a liquid would, then we would have a packing factor of 1. Packing factor of 0.74, that's like saying, so the remainder from 1 is 0.26. That's like saying 26% of our space is wasted when we pack golf balls together, when we pack solid spheres together. When we do all this, we get 850,000 golf balls. That estimate, our estimate up here was 900,000. Actual number is 850,000. That's a really, really good estimate. Doing just a tiny bit of math, especially when we're limiting our number of sig figs, we have less than a 6% error, which is definitely closer than I was willing to hope for. But that's how I might take the idea of modeling. I modeled my bus as a box. I modeled my golf ball as a cube. And even though the golf ball as a cube thing might seem a little bit ridiculous, I was able to get an estimate that to 1 significant figure is dead on. To 2 significant figures, I'm still less than 6% error. That's the idea.